Okay, question 21. Reactants A and B are placed in a 1 litre container to form C. Reaction reaches equilibrium. Explain why the reversible arrow is used in this reaction. 1 mark. So that's some sort of dynamic equilibrium definition, explanation, I'm assuming. The arrow represents the reaction going continuously in both directions at equilibrium. Both rates the same, so concentrations stable. It also indicates shifts can occur to the other side. I'll just add the word dynamic in there before I check. Okay, what do we got? The reverse indicates reaction occurs in both directions simultaneously. Explains forward and reverse occurs simultaneously, continuously in both directions, both the same, so concentration is the same. I didn't use the word simultaneous, but they haven't underlined the word simultaneous. I did say both directions continuously and at the same rate. So I think that would get a mark. Alright. Guess they just didn't ask questions like that, to be honest. Anyway, deduce whether the equilibrium for a reaction lies towards the reactants or products, explaining your reason. Okay, so Kc equals products over reactants. So a low Kc, high Kc, 9.9 by 10 to the 2, means products are greater than reactants. So reaction is mainly on product side. Reactants go to products, therefore mainly on the right hand side. I don't know, that's a thorough explanation. I'm not going to look for 4 points on that one. Kc is greater than 1. I didn't say greater than 1, I said it was high. Therefore, equilibrium for the reaction lies towards the products. I did definitely say on the products, I said it was high. Did you say it lies towards the products? Correct. Explain Kc is greater than 1. I didn't say it's greater than 1, I said it's high. And products over reactants, which induces the fact that if 1's greater than 1, has to be greater than 1, so that's implied. And it's actually a much better answer than greater than 1, because greater than 1 is just memorization, and this is actually understanding. So they'd be pretty daft to give the inferior answer. Greater than 1 is memorization, that's bad. Alright, this is understanding, so they'd be a pretty bad marker to not give a superior answer to the mark, but you never know. Alright, you just never know. Alright, describe the type of reaction that occurs when amino acid monomers are joined to polypeptides. So that's a carboxylic acid. So a carboxylic acid, the alcohol group from reacts with the hydrogen from an amino group NH2 to remove H2O, water. The peptide. This is four points, by the way. There's one there, one there, one there, one there, one there, one there. The peptide bond. So H2O comes out, and NH is formed. 2 marks, 2 lines. That's just craziness. Considering we're trying to get it correct, we need to write 4 things. Condensation. God, how many words can you fit in 2 lines? When amino acid bond is joined to form a peptide bond, water is removed. Identifies condensation reaction. Describes water is removed when the amino acid joined to form polypeptides. Water is removed. And I didn't say condensation. It does say type of reaction. So that was my fault. That's the key question. I should have said condensation. Quite clearly, that is my mistake. Describe. It doesn't actually say state. So I'm taking that back. You should have said state the reaction. I just went straight in and described it without stating it. So even though I get 1, that is clearly a fault with the question, because even the question says identifies or state, but the question didn't say identify or state, it just said describe, which I did far better than the mark scheme did. So again, I think this just goes without question why no one got 100%. There's clearly big issues with the questions and the mark schemes, as usual. But now they're just getting crazy. So even our hyper-intelligent students, which are probably smarter than the chemistry teachers, to be honest, if you know these guys, they corrected our PhD senior teachers. They're that good. That is a mistake. All right, so I lose 1 because of that. So let's just move on. Still God mode. Well, the problem with God mode is that putting 2 lines there, and I wanted to say more and I just can't. And I've already said 5 or 6 different things. But I haven't just identified or stated though, which you always do for these 2, 3, 4 mark questions. There's always something obvious in there, which was I was meant to state, not describe. State and describe. That's what they should have said. Identify the bond formed when amino acids. So that's a giveaway. Identify the bond formed. You can't ask for anything more than peptide. You can't ask for it to be drawn. Then there's a real issue with the exam. Just peptide. So that's a bit of a giveaway that needs to be removed. Maybe if I marked it second, I would have thought, ooh, have a quick look at this, because now you might not have 4 things. Okay, so 1 gone. Okay, disclaimer, this is one of the questions that I know about, one of 2 that were issues. This was an issue because the students didn't realize sodium hydroxide absorbs water, even though it's in my experimental videos. So I was a little bit annoyed. I couldn't believe none of my students knew that. It's just showing that they don't watch the experimental videos, which I can tell from the number of views on them. So I keep on emphasizing the experimental videos are more important than anything. The textbook, even the mark schemes, right? There's nothing more important than the experiments, and Only 2 students. One of them was from our school. Got this correct in the entire state. So only 2 students got it correct, which is really amazing. All right, I think mainly because sodium hydroxide pellets solid is too dangerous, and so you never give it. We never give it to students anyway. So it's people would never have experienced if they didn't watch that video, which most people haven't. The titration videos, which is sort of mandatory watching that video. How to do a titration. The titration method questions pop up in these exams and almost nothing else does. But they pop up all the time. But you should be watching all the experimental videos because that's the only thing that really matters, the experimental evidence. So anyway, this is the question. So I'm also aware of the fatty acid one. Disclaimer. The rest I've got no idea about. And the rest of this question I've got no idea about. So an aqueous solution was titrated with 30 mL of potassium hydrogen phthalate aqueous. Okay. So that's a little bit unreasonable because people won't know why you did it against this and why this is better than sodium hydroxide. So that is an issue. That's assumed. There's a lot. This is a stable compound, but no one's going to know that. So that's really not a fair question. Determine whether it is a strong acid. So this is whether it's a strong acid or a weak acid. Identify from the titration. There's not enough background in that. Don't know why it's so short, because that's key information. So here, so there's not that little curve that there should be. Anyway, but that's all right. So there's a mistake. It's one mistake in the curve. Okay, so it's strong. Identify one feature from the titration curve to support your reason. Okay, so KHP is a weak acid. It's very straightforward. It has to be a mark without needing to do God mode. Identify one feature. Now that you want to put at least 2 things. The initial pH of KHP is around pH equals 4. Well, it should be 2, 4, 6, 8, so it must be 0.4, 0.8, 3.2, 3.6. It's around 3.6, plus minus half the smallest increment. It's around pH 4, but I'll put it in there. The equivalence point, this is the second point, has a pH of greater than 7. I put also, so they know that's another reason. And that would be a 10-mark question to explain that. So how do we go? 23A. KHP is a weak acid. That always had to be just a quick and easy mark. Titration contains a buffer region. Oh my God, I should have written 3 things. I should have written 4 things. Oh my God, they're not allowing anything else? Identifies the buffer region. But that's not even a buffer region if it's a weak acid. That's actually an inferior answer. Because if you haven't identified this as a weak acid by the initial pH and the equivalence point as above 7, and if you can't, that's how I identified it, then you can't confirm that that's a buffer region. So this comes first, these 2 points, therefore this comes second, therefore you can now say this is the third point. So the mark scheme's actually wrong here. I would allow that. Actually, I wouldn't even allow it because that is not... it's a feature of the titration curve, but it's not a feature of the titration curve to support your KHP reasoning. Oh my goodness. Wow. Wow. Okay. This really was impossible to get 100% on. All right, we're only the third question in, and there's no way you can get that. I wouldn't even have mentioned it because it's incorrect logic. Okay. Far out. I'm in shock. I should have been in shock, you know. These were hyper intelligent students. I was expecting half of them to get 100. I'm not kidding you. That's how smart they are. And they didn't. They got 99s and 98s and stuff. One of them got 100, but it wasn't my class. It was our classes as a team or whatever. But wow. Okay. Explain what was used as standard solution rather than NaOH. That one I was annoyed at. So NaOH is hygroscopic. I thought this must be specifically the one that only 2 students got correct. So error in measuring the mass must be standardized. This is God mode. Therefore, KHP must be a stable, non-hygroscopic. Comparison. Brackets acid. I actually expect students to get that. No one did. All right. KHP does not absorb water from the air, therefore an accurate concentration can be determined. Okay. Explains KHP does not change the absorption of water in the air. My God, that was God mode there. All right, and I only just scraped that one in. All right. Is hygroscopic. Eek. Even I almost didn't get that one right. Calculate the concentration of NaOH, show you're working. All right, NaOH, I hope this is nice and easy. Yes, 25, good. So we got 25 mils. I hate turning pages, it's really annoying. 30 mils, 0.012 KHP. 30 mils, 0.012. So is it 1:1? It's 1:1. I'm not going to rewrite it because it's here. And I just checked that it's balanced. Looks balanced. 2 hydrogens, 1 oxygen, sodium, Kp. All right, all balanced. 1:1:1. Okay, so concentration. KHP, always write formula substitute units, number of moles and volume. Number of moles. KHP equals C times V. 0.030 times 0.012. What is that? 0.03 times 0.012, 0.00036, 1, 2, 3, 4 moles. 1 mole KHP is to 1 mole NaOH. So 0.0036 is to X, therefore X equals 0. Always do that. 0.0036 moles NaOH. Concentration NaOH equals number of moles of volume. 0.025, 5.025, 0.10144 moles mole per liter NaOH. 2 marks. As long as you do your calculations nice, you should be right. Provide suitable substitution. Into what? Into that. Provide suitable substitution. I don't know what that means. Calculates NaOH, we did that. Well, we've done everything correct. All the formula substitution. So you can't do better setting out than that. Question 24. The pKw of pure water at various temperatures was determined To investigate the effect of temp on equilibrium, position, ionization of water, and this is normally pH, they've got pKw. So 25 degrees, 14, that makes sense. Explain the effect of increasing temperature on the pH of water by considering the enthalpy of the forward reaction. We start with your equations. So it's heat plus H2O. All right. Probably won't get your mark, but you always write equations regardless. Okay. So increasing on the pH of water, increasing the temperature decreases the pKw as it is an endothermic reaction. Got to say 8 things here. So more heat causes reaction to push to right hand side, with the products being increased H plus and OH minus, therefore decreased, that's a trick, pH and POH, as pKw equals pH times POH. Okay, that's 1, 2, 3, 4, 5, 6, 7. 7. I need 8 things. Explain the effect of increasing temperature on the pH considered. So increasing temperature, I've already said, decreases pH. It's endothermic. 7 things. I can't think of the 8th thing. It's got to be okay. Mark scheme. As temperature identifies pKw decreases, temperature increases. As increased temperature decreased pH. Thanks, little doggy, for barking. Determines the forward reaction as endo. Yes. Explains increase in temperature shifts towards products. It said that. Explains increase in temperature decreases pH. Decreased pH. Easy. All right. Question 25. Can I do organic chemistry without having seen it for a year? That's the big question. Disaccharide. Identify whether alpha glucose is aldose or ketose. They should cut back on the organic, not because I'm happy that they've removed it. They shouldn't have removed it, but they have removed it, so there's no point writing in there for these exams, is there? So there's the alpha glucose, and it is an aldehyde. It's a CHO, not a ketone, which is the fructose. Identify, it's an alpha glucose. It's an aldose. What's the point of that? I don't know. Whatever. A aldose monosaccharide. Why is aldose monosaccharide? Well, I said aldose. It's repeating the question, right? Don't get marks for repeating questions. Aldose should be good enough. Distinguish alpha glucose and beta glucose. So, this is the one that's, the first one is the one that's, this is alpha, and then reverse it is beta, and this is 1, 2. 2 marks. For alpha glucose, the hydroxyl group on the C1 carbon is downwards on the Hayworth projection. I think it's called Hayworth. Data book, page 11. For beta glucose, this is reversed. So the hydroxyl group is upwards. How is that worth 2 marks? It's just kind of stupid. The question is just memorization. Reverting to biology. The antiphase that I've got has opposite sides of the rings for trans. I'd never be the same side of the ring for cis. So alpha glucose is opposite of the ring. It's opposite in relation to CH2. It's just another way to say it. There's a million ways to say it. And on the same, for beta, it's on the same side. It's upwards, which is the same side as this other group. So I've said it on the C1 carbon. I've done it on the right places. Okay. So you have to get a mark for that. Such a silly question. I don't even want to deal with it. Question 26. The aqueous iodate, potassium iodate, reacts with potassium iodide. It's being balanced unless they're trying to trick you. I'm sure they're not. Dilute head to form solid iodine. The overall balanced equation is shown. So they're stating that. Identify the reducing agent. Explain. Determine the reduction half equation. Okay, finally they put a balancing in here. Okay, reducing agent. So they're ions that displace. So this will have to be +1. This will have to be -1. That's -2. It's a total -6. +1. So we've got a +1 here. So we need a total +5. They try to be tricky again by having everything go to one thing. So this one gets -1 to 0 is increasing, so that's oxidation. And this one's +5 to 0, so that's decreasing, so that's reduction. Okay? So that means it's the oxidizing agent, and that means it's the reducing agent. So, Ki, in Ki, the oxidation number for I is -1, which has 2 marks. That's 1 mark, which goes to I2 with an oxidation number of 0. It says don't write outside the box. This is an increase in oxidation number. Therefore, it is oxidized. Therefore, it is the reducing agent. I probably said 6 things, at least 4. All right. Identifies iodide in Ki is the reducing agent. I didn't write I-. That's a sticky note. I would say you get that wrong. And if I was iodide, it's in brackets though, but I didn't say iodide ion. Ouch. Yeah. Explains I is oxidized by losing an electron. What? losing an electron. Increase and decrease oxidation number is okay. Losing an electron is another way to say it. And I didn't say iodide, I just kept going, so that would be error carried forward. So I'm only giving myself 1 mark. Be really careful. That is in differentiating between the iod. If I said the oxidation for the iodine in potassium iodide, the iodine in potassium iodide is an ion, they might let you get away with it, but I would say because I didn't write I minus, I would lose a mark. So learn your lesson. That's being careless. Having just electron lost is probably not as good as an answer as that, because its oxidation number changes. They're not strictly, there's no strictly electrons gained or lost. It's not ionic and covalent bonding. If you look at the bonding triangle, it's going a bit too much in depth, but we'll just leave it at that and keep it simplified. Really 2 marks, they shouldn't be doing this 2-line thing. Give us the space to elaborate. I ran out of space, which is the main reason to stop. I could have said losing or gaining electrons, but I still wouldn't because it's not technically correct. The electron is not 100% here. It's not 100% going to one side or the other. That's not scientifically correct. It is a simplified version of the bonding, so they shouldn't really focus on that. They should really focus on what we learned, which is oxidation numbers to determine which is reduced and oxidized. Reduction half equation. So that was oxidized, so the reduction one is this. So KiO3 goes to... that's annoying because the K is a spectator. So I'm going to go IO3 minus goes to I2. And then I'm going to balance it. So if it was easy to leave the spectator ion in, I would. So first step is to balance these things. Again, 3 marks. Wow. I think I'm in trouble. I think I'm in big trouble. And then balance it for water, for oxygens, and then H pluses. So H2O, I'm going to need 3 of those. And then I'm going to need 6 H pluses. Skipped a step, sorry, but I won't skip the next one. So that's 6 minus 2, so I need a total of plus 4, right? So I need to add 4 electrons. Three marks with 2 lines. Are you serious? It's a bit harsh. All right. I think I've balanced for charge. We can usually ignore states on these ones, but I won't. Just don't take the risk. And that should be balanced. What the hell's the mark scheme going to say? 3 marks. Determines IO3 are reactants. Whatever that means. Why would it give a mark for that? And the products. Determines a balanced half reaction. So I've stuffed that up. 6 H2Os. I2. So I've got 2 out of 3, and I haven't balanced it right, which is interesting. What have I done wrong? 3 oxygens. Oh, there's 6. Yeah, stuff that up. Easy to make mistakes, isn't it? So there's 6 oxygens there, not 3, because I times it by 2. Yeah, okay, so I do need to correct those. Yeah, I'm not having a good one. I actually get 2 out of 3 for that. So I forgot, I made a mistake here in seeing that there's 6 and then that carries through to these numbers. And I'm just going to leave it. All right, just got to be honest with that. Okay, kind of annoyed about the lack of space, but that's all right. That's still my mistake. Okay, so this one, the fatty acid one, is the other one that I'm aware of that was a disaster. Because, what is it? Solvent magnesium oxide. You've learnt the transesterification, I think it's a base catalyst or something, and this is like a 2-step acid catalyst, so it's outside your syllabus. And though I'm aware of, because people told me they did the God mode and got it correct, I don't like my chances. Even though I'm aware of it now, so that's sort of me cheating. I know there's an excess of fatty acids that you turn into esters. And then the esters plus the ols and alcohol can go into the biodiesel. Would I have known that otherwise? I don't know. Not with a test like this. It's really, really long. It seems excessively long. This and quite traumatic. This paper. So a series of experiments was from optical conditions, acid esterification. So you're creating esters, and then the esters plus the alcohol go to. So yeah, maybe it is. All right. Unfortunately, I know about this question and the hygroscopic one, so I can't give an honest. The hygroscopic one was super easy and should have got that. No one did. So even more people got this one correct. So I've got to assume it's possible. All right. Experiments measured the effect of these things: catalyst, temperature, concentration. Temperature was held constant when investigating the effect of catalyst concentration and ethanol to seed ratio. So, identify the optimal conditions to maximize biodiesel production. So you want here high concentration, low ethanol to seed ratio. You want them at these places, I guess. So catalyst optimal conditions, you want the catalyst concentration to be high. Example 4%. That'll give you like a 92. This is only with 1 mark too, which is unusual. And then you want the ethanol to seed ratio to be low, because you want it up here. So maybe example 10 grams per grams ethanol to seed. So high ratio, that gives you 92.5. Then that one is 93. And then the temperature doesn't matter too much, but you want a high temperature. Example 45 degrees. Wow, I'm. It's a bit weird. I'm a bit worried about that. This one. So identifies optimal reactions as 4% catalyst, 10 to 1. I don't know if I get that because I didn't say 10. Well, technically there's an implied 1 there. So you'd have to give that. That's a lot to take in for 1 mark. It's a bit excessive. Okay, so here are the tricky ones. Explain both the esterification change used to optimize biodiesel. Why both esterification and transesterification? So you must have thought there's a lot of fatty acids. Okay, so step 1, and it's 3 marks. There's so many. Step 1, esterification implies. So this is seed oils. Implies seed oils are high in fatty acids that need to be converted to esters for the second reaction. Optimize. Ethanol, step 2. I have no idea what they're asking for. Step 2, the ethanol reacts with the esters to create biodiesel, which is another form of ester. So that's why it's called trans-esterification. Magnesium is a nanocatalyst. Magnesium nanocatalyst increases surface area. I'm at a loss for this one. I think this one's so difficult. I'm just keeping it at 3. I can't think. I'm 6. Oh, I don't know. I'm just going to leave it at that. So, explains that esterification converts free fatty acids to esters. Yeah. Explains transesterification converts esters to fatty acid alkyl esters. Biodiesel. A two-step process. Max explains that a two-step. That's just reinterpreting the question. I wonder if they've tried to scam 3 out of nothing. Transesterification converts esters to fatty acid alkyl esters. That's probably better. Biodiesel, which is another ester, that ester with these ones. Ethanol with those esters is probably clearer. A two-step process max. Let's explain why both. That third point makes no sense at all. I'm still going to give myself 3 because I've said something that's actually of value rather than restating the question for the 3rd mark. All right. Rough, very rough. So 3, I think so. All right. Determine the effect that catalyst concentration, ethanol to seed ratio, and temperature on biodiesel use data. What? We've dealt with that already. I'm going to repeat. Catalyst have on biodiesel use data to support your reasoning. And we have to keep flipping the page. I'll just open it up on the other side so I can look at it. That really seems like a waste of time. Increasing catalyst concentration increases yield. Oh my God, really? Example 0 to 4 increases. So relationship with data, 91% to around 92.5%. Why would they do this? It's like a data test. There is a cost here though. All right, there's 3 points. Next one, increasing ethanol to seed oil ratio decreases percent yield. Example 10 to 18 leads to greater than 93% to around 91.5% yield. Again, cost comparison of ethanol versus seed oil needs to be considered. Temperature is less critical with a less steep gradient. Increasing temperature decreases yield. Example 90 to around 92.5 to, around 45 degrees to 70 degrees Celsius is only decreasing yield around 92.5% to around 92%. So cost of heating versus speed of reaction needs to be considered. Wow, they should ban 4-mark questions for chemistry. Leave that to the biologists. This is horrible. I'll write 8 things. Just let me find the answers, sorry. Determines the increase catalytic electricity, increase yield, determines the increase ethanol, decreases by, determines, that's just stupid. Identifies data from the graph supports, and I got data, okay. So definitely killed that, but annoyed that it was there. And I added extra. All right, so that was God mode for that one. And we're still going, question 28. This must have brought some students to tears, this test. All right. Explain why the isomer is a saturated compound. It's just excessive questions. All right. Just don't need this many questions, do we? I need to check. It's got to be more questions than in the past. All CH bonds are single, no double, triple. Okay, all carbons have 4 single bonds. Therefore, saturated. I don't know what the. I don't know about these questions. Contains only single bonds. Isomer saturated contains only single bonds. Yeah, whatever. All right. Identify whether the isomer is a primary or secondary halogenic alkane. This gets people all the time. They made it super simple. I'm just going to say primary. Because it's bound to no other carbons or one carbon, so they have picked on the they have picked on the trick. Primary. Pointless. They should leave these ones to multiple choice, and those calculation questions they should put in here and make them worth more. Just get rid of that stuff. Leave it to multiple choice. Determine the structural formula of another isomer of this that is tertiary. Apply UPAC rules to name it. So obviously you're just going to put it here. That's what they're going to be looking for. Draw all the bonds correctly out, unlike what they have done there. Cl. I'm assuming there's no other way to do that. Okay. And apply the UPAC. And so that is 1, 2, 3, and there's a 2-methyl and a 2-chloro. Chloro comes first alphabetically, then methyl. So 2-chloro, 2-methyl propane. That's good. That multiple choice question, I think, instead of wasting our time having to write something. 2-chloro, 2-methyl propane, determines structural form, determines UPAC name. All right, easy. If you make a mistake, I'm never referred to this mess at the back, which is a waste of paper. You talk about killing trees. one. Look at all that paper at the back. It's hard for you as the student, and it's also hard for the marker to be jumping back and forth. So they just need to give you the proper space, so the student can just answer the question without having to work out where the hell they are back here, and then having to read it, and then the marker's probably going to miss it anyway and not even mark it. So yeah, stop doing this, please. Now, finally, last question. Okay, methylamine is weak base, forms a buffer solution when mixed with methyl ammonia, some sort of salt. Methylamine, that's salt. Fair enough. Describe, using a diagram, the structural formula of methylamine for 1 mark. Methyls 1, amine in H. Methylamine, weak base, CnH2. All right, that should be fine. Check our answers. Oh, got to be careful of that. They have been inconsistent. But just don't take the risk, okay? Maybe I just got away with it here because they're inconsistent here and they haven't specified that every line must be drawn, but that's just me getting slack, okay? Just don't lose track of things like that. Okay, apply Le Chatelain's principle to explain how methylamine, methyl ammonium buffer solution resists a pH. Oh, finally. They finally asked it. All right. So, would resist change. Okay. So I've got the equation up here. So what you're going to do is if you add more H plus, all right, then it will react with the OH minus on the right hand side. So it'll be H plus plus OH minus goes to H2O and remove, neutralized. This will cause a decrease on the right hand side, so reaction will move to right hand side, so OH minus is replaced and pH remains constant, relatively constant, remains relatively constant. All right, adding OH minus. Oh, sorry, I've only meant to do that one. Damn it, already thought I said too much. Oops, I was in brackets. Adding the OH minus, oops, will increase, I think I'm just getting too tired, increase the right hand side. This will cause CH3NH3 plus to react and move the reaction to left hand side, effectively removing the excess. That's the question they should have asked. They should have asked for both, so they can test whether students actually understand why it's a buffer. Excess OH minus to keep pH relatively constant. Sorry, I got carried away and was answering the question they should have been asking. They got halfway there. They're always a bit scared to ask the good questions, I feel. Explains how it reacts with OH ions. Yeah, did that. Explains the equilibrium shift to left, resist change in pH. Yeah, I said that. All right, done. Make this one the 4-mark question. All right, so the silly definition memorized. All right, hope you did better than me. I do expect you to do better than me, guys. All right. I didn't study for this, and I was a little bit flippant.